Okay, let's jump right into this explainer. Imagine, just for a second, what it'd be like if you spent your entire life floating in a calm, supportive pool of water, and then, suddenly, you had to step out onto dry land. Right? That is the incredible evolutionary journey we're diving into today. We are exploring terrestrial and aerial habitats, so life on the ground and life up in the sky. It's a completely different world compared to living underwater, and the plants and animals that call it home have had to develop some absolutely mind-blowing strategies just to survive.
Now, before we get into the really cool details, we've got to understand what an adaptation actually is. Think of an adaptation as nature's ultimate survival toolkit. It basically means the special features, like physical traits or specific behaviors, that plants and animals have evolved over thousands of years. They literally need these tools to survive and reproduce in constantly changing conditions. We're talking about battling extreme temperatures, dealing with different humidity levels, and handling intense sunlight. If an organism can't adapt to all that, well, it simply won't survive.
Here is our roadmap for today's explainer. 1. Challenges of the habitat. 2. Surviving the elements. 3. Moving and sensing. 4. Standing tall on land. 5. Amazing adaptation examples. And 6. Why adaptations matter. Let's get going.
Organisms on land don't just hang out in one type of place either. As you can see, they have to cope with a massive variety of environments, transitioning between dense forests, wide-open grasslands, scorching deserts, and freezing mountains. And every single one of these zones has its own unique set of rules for survival.
Section 1. Challenges of the habitat. Facing the great outdoors. So what actually makes living on land and in the air so incredibly tough? Well, on the plus side, there's plenty of oxygen in the air, way more than you'd find in the water. But honestly, that's where the easy part ends. Out here, organisms face massive temperature swings. We're talking boiling hot during the day and freezing cold at night. Plus, because the humidity is so much lower than it is in the water, there's a constant, really dangerous risk of just drying out. Add in the strong sunlight and ultraviolet radiation that you definitely don't get deep underwater, not to mention the physical effort of moving through thin air or across rough ground, and you've got a pretty hostile environment.
So that begs the question. If the air is constantly trying to pull moisture out of your body, how do these living things avoid turning into dried-up raisins? And how do they actually capture that plentiful oxygen? This leads us directly into our next section.
Section 2. Surviving the elements. Water and air.
Conserving water on land is absolutely critical. Without it, biological processes literally just shut down. And that's exactly why different animal groups have evolved their own built-in weatherproofing. Reptiles, for example, have dry skin covered in tough, horny scales that actually lock moisture inside their bodies. Birds are covered in specialized feathers that don't just help them fly, but act like a raincoat to protect them from the cold and the rain. And mammals, well, we use hair or thick fur to stay warm and trap precious moisture right close to our skin to stop evaporation.
But hey, keeping water inside is only half the battle, right? They also have to breathe the air. Now, unlike fish that use gills to filter oxygen from water, terrestrial organisms have to extract oxygen from a gas. Mammals, birds, and reptiles do this by using lungs, which are organs that expand to pull in air. But insects, they do something entirely different. They use this wild setup called a tracheal system. It's basically a microscopic network of tubes that delivers air straight from the outside directly into their individual cells. How cool is that?
Section 3. Moving and sensing. Navigating the world.
Moving efficiently out here is literally a matter of life or death. If you can't catch your food or outrun whatever is trying to eat you, you're not going to make it. And that explains why we see such specialized limbs. A cheetah, for instance, has these incredibly strong, muscular legs built for explosive running and jumping. A swallow or a butterfly has evolved incredibly lightweight wings to conquer the sky. And ground dwellers, like horses and foxes, well, they use specialized claws, soft paws, or hard hooves to firmly grip the earth while they move.
But here's the thing. Movement is totally useless if you don't know where you're going. That's why sense organs are the ultimate survival tools. Just think of an owl's massive eyes, built for keen night vision to spot prey in the dark, or a rabbit's movable, radar-like ears that catch the absolute faintest sound of danger. Cats and rodents use super-sensitive whiskers to literally feel their way through tight spaces. And of course, foxes and dogs have a brilliantly strong sense of smell to track down a meal from miles away.
Out in nature, it's basically the ultimate game of hide and seek happening every single day. Predators use their adaptations to hunt, and prey use theirs to escape. It's a constant arms race where these complex senses and movement abilities dictate who gets to eat and who gets away safely.
Section 4. Standing tall on land. The fight against gravity. Think about this for a second. When you're swimming, the buoyancy of the water holds you up, right? It makes you feel super light. But the moment you step onto land, gravity is constantly pulling you down. So how do you stand up, move around, or grow tall without that water supporting your weight? To fight gravity, nature came up with two brilliant solutions. For massive animals like the elephant or the camel, the answer is heavy-duty internal architecture. They use strong, dense skeletons pulled by powerful muscles to give them upright support. Plants, on the other hand, have a completely different strategy. A mighty oak tree relies on deep roots to absorb water and minerals while anchoring itself firmly into the ground. It uses stiff, woody tissues in its upright trunk and stems to give it the incredible strength it needs to grow high up into the sky toward the sunlight, which is where its leaves carry out photosynthesis.
Section 5. Amazing adaptation examples. Nature's Hall of Fame. Let's look at some absolute masters of adaptation, starting with the camel. It is the ultimate desert survivor. Its humps actually store fat, not water, which gives it energy when food is super scarce. It has these extra long eyelashes that act like windshield wipers to block blowing sand, and wide feet so it doesn't sink into the soft dunes. Then you have the fox, a highly adaptable predator. It relies on excellent hearing and an acute sense of smell, thick fur to trap body heat, and fast, agile legs to thrive out in the forests and grasslands. Up in the air, birds are built kind of like airplanes. They have streamlined bodies to reduce air resistance and hollow bones to make them incredibly light, plus feathers for flight and insulation. Butterflies also rule the skies with extremely light wings, but they protect their bodies with a hard outer shell called an exoskeleton and use tiny antennae to smell and feel. Meanwhile, back in the scorching desert, the cactus survives by doing the exact opposite of a normal plant. It stores huge amounts of water in a thick, fleshy stem, and instead of broad leaves that would lose moisture, it's covered in sharp spines to prevent evaporation and keep thirsty animals away.
And I've got to share some of these fun facts because the scale of these adaptations is just wild. Did you know some bird species migrate thousands of kilometers across the globe just to find the right temperature and food? For plant reproduction, dandelion seeds literally have built-in parachutes so they can travel by wind and plant themselves in new soil. Chameleons can change their skin color to blend in, but also to regulate their body temperature. Hedgehogs roll into spiky, uneatable balls to protect themselves. And many plants have a feature called phototropism. They literally move and bend their bodies to turn toward the sunlight throughout the day.
Section 6. Why adaptations matter. The ultimate goal. Ultimately, every single adaptation we've talked about today, every feather, every scale, every deep root, and every sharp sense of smell, exists to help these organisms do a few absolutely crucial things. They need to find food and avoid becoming food. They must survive the extreme heat, freezing cold, and severe droughts of their environments. And they need to survive long enough to reproduce successfully and raise their offspring. By doing all this, they thrive in different habitats and maintain a healthy balance in nature. When you look at the big picture, whether it's a cheetah sprinting across the savanna, a cactus quietly storing water in the blazing sun, or a bird migrating across continents, these specialized traits are the key to everything. They are the tools that unlock life outside of the ocean. Without them, the vibrant, diverse world we see around us just wouldn't exist.
I want to leave you with this really important thought. Life on land and in the air is full of challenges. Thanks to amazing adaptations, plants and animals can survive, grow, and reproduce in a wide variety of environments across our planet. Next time you step outside, really look at the trees, the birds, or even the bugs on the sidewalk. You're looking at millions of years of survival engineering in action. But it makes you wonder, as our planet's conditions continue to shift today, what will the adaptations of tomorrow look like? Thanks for joining me on this explainer, and keep observing the amazing world around you.